Now we're going to practice a simple scaling problem using the ideal gas law. So the setup is an ideal gas has an initial pressure of 2 bar. What is its pressure after its volume is doubled and temperature is tripled? If you've had practice before with scaling problems, also known as proportional reasoning, you may even be able to do this in your head with the ideal gas law. If you haven't, let's go through the formalism of how to solve these, because it's something that's very important, very useful, and for some people difficult. I'm not giving you any information about the volumes and temperatures specifically, I'm just telling you how the initial and final values are related. If you haven't done that sort of reasoning before, it's kind of tricky the first time, so let's go through it. So here's our parcel of ideal gas, and I'm just going to write my favorite version of the ideal gas law, PV equals mRT. We know that the initial pressure is 2 bar. The final pressure, well, we don't know that. We're trying to solve for it. Now we have to write out the relationships between the initial and final volume and the initial and final temperature. Okay, so the volume is doubled in going to the final state from the initial. That means that V2 has to be bigger than V1 by a factor of 2. So V2 equals 2V1. Likewise, the temperature was tripled. Same argument, T2 equals 3T1. Those are our givens. Now let's solve for the final pressure. So we start with the ideal gas law, and we can take a ratio. We did this in the introduction to polytropic processes for ideal gases, so I'll go through quickly. The initial side is on the left, the final side is on the right. We can cancel MR because we're not changing the mass or composition of our ideal gas. That gives us that PV over T is the same for the initial and final states. Okay, let's solve for P2 over P1. So we do that. And remember, we can't simply quote the relationship for a polytropic process. We have no guarantee that this process is polytropic, so we better just do it using our ratios in the ideal gas law. We'll move this up. Now we can plug in our ratios, right? We need V1 over V2, so V1 over V2 is 1/2. It's not 2. T2 over T1, well, that is 3, so we'll plug in those numbers. And now we get the P2 over P1, it's 1/2 times 3, which is 1.5. We don't have the answer yet, but we're pretty darn close. Now we just need to solve for P2. Well, P2 is 1.5 times P1, and we knew that P1 was 2 bar. 2 times 1.5 gives you 3. So the final pressure is 3 bar. I encourage you to practice this sort of problem solving. It comes up a lot for things like ideal gases, and can be challenging the first time you set up these problems. But once you've practiced, you should be able to do a problem like this in a minute or two without any trouble.